All right, here's lesson 4.03, independent practice. I'm not going to start with number one and number two. I'm going to start with number three because those are the easier ones. Three, four, five are easier. One and two are a little bit more complicated. So I want to start with number three. And basically, we are working with equations that look like this: x to the third power equal q. Okay, so like for example, look at my example here. This is like problem number three, a similar one. X to the third power equal 512. And what I want you to do is imagine every time you see one of these equations, imagine a cube where inside you have 512, and you want to find out how much are the edges of the cube. Remember, cube, all these lines, they're called edges. They're exactly the same. So basically, I'm looking for one number multiplied three times by itself. It will give me 512. You can do it by looking at the table. If you look at the last column of this table in green, you can find 512. You can see it's right here. I highlighted in green. And you can see that 512 is in the row of 8. So that means each of these x's are 8s. Or in other words, the value of the x is 8. Now you don't always going to have the table. And if you don't memorize the table, you're going to have to use a calculator then. And here is the calculator. And this problem is the same thing if I would have done the cubic root of 512. Okay, so go to the calculator, press this key here, this one, look at my little finger, then type that little 3, and then inside you put 512. And you can see you get the same answer. Okay, let's go to the next one. So here is question number 4. Remember, I started with number 3. Now I'm doing 4. Then I'm going to do 5. And then I go back and do number 1 and number 2. Okay, so in number 4, again, I gave you a similar one. So they gave you the equation x to the third power equal 216. When you see this type of equation, that you see the x with the exponent 3, okay, imagine a cube where 216 is inside the cube, and you want to find the edges of the cube. How much are the sides here of this cube? Okay, we call the lines edges. All right, and basically, this problem is you're looking for one number that multiplied 3 times by itself. It will give you 216. Now, one way of doing it is looking at the table. Look at the last column, the green column, and look for 216. And you can see, look, 216 is right there. And 216 is in row 6, which means that each of these edges, each of these x's are 6. So you basically already found the answer of the equation. It's going to be 6. But if you do not know the table, then what you're going to have to do is, this is the same thing as doing the cubic root of 216. And you can use the calculator. And that's what I'm going to show you. So click on this key, type the little 3, inside you write 216, and you can see you get the same answer. Okay, let's go to the next one. All right, I'm doing now question number 5. This is like a word problem, but it's really the same thing I have been doing with this cube. So it says there is a cube with a volume of 125, it should say here, cubic feet. But anyway, my point is that imagine a cube. Now, I'm not going to use 125. I'm going to use 64. So you have a cube where the inside of the cube, we call that volume, is 64. And you want to find the edges of the cube. You want to find out how much is each edge, each of these x's. So basically, this problem is like the equation x to the third power equals 64, like I did the previous one. Okay. Now, one way you can find how much are the edges, look at the table, find 64. Here it is. I highlighted. We are in row 4. So that means each of these x's, each of these edges are 4. Or put it this way, x is going to be 4 because 4 to the third power, 4 times 4 times 4 gives you 64. Now, if you do not have the table, you're going to have to use the cubic root of 64. And you're going to have to use the calculator. And here's the calculator. You're going to press this key, type the little 3 inside the gray box, type 64, and you can see we get the same answer. Okay, now let's go back to problem 1 and 2 because those are a little bit more complicated. Okay, now I'm back to question number 1. Now these, you're going to have to do it. This one, you're going to do a little bit more thinking. You're going to see why now. So they gave us x to the third power equal that number, but I changed it to this one, 2048. Now, when you see these equations, imagine a cube where the inside, the volume, what is the inside is 2048. Okay. Now, what I suggest, if you have the table, try to find this number in the table in the green column. And you're going to see that this number is not in the green column. Okay. And here's why. It's because 2048 is not a perfect cube. Or put it this other way, if I use the calculator, I am going to do the cubic root of 2048. And look what happens. Okay. Cubic root of 2048. And you can see I get this long decimal. When you get this long decimal, this is not this number is not a perfect cube. Okay, so basically what I'm going to do is I am going to do the tree. Okay, every time you get these long decimals, we're going to do the tree of the number inside of the cubic root symbol. So here's what I suggest you do. This number is even. So I'm going to take 2000. You can see I'm going to show you the calculator. 2048, I'm going to divide it by 2. So you can see I have here 2 and 1024. Okay. And I'm going to circle the 2 because I cannot do a tree for the 2. But 1024 is even. So I'm going to do a tree again. Okay. Now look what I'm going to do. I'm going to show you another trick with the calculator. I'm going to press the blue button to go new line. Since my last answer is 1024, if I click this key, it's going to show up again. See? And 1024 is even, so I'm going to divide by 2 again. And you can see I got 512. So 1 here goes 2, here goes 512. Now I'm going to circle this 2. Now if you look closely, 512 is a perfect cube. Look, it's right there. And you can see that we are in row 8. So that means that 512 can be done using 8. So instead of a tree with 2 branches, imagine it's a tree with 3 branches. I can use that 8 3 times. And cubic root means you're looking for a number that is repeated 3 times. So you can see that 8 is repeated 3 times. So my answer here is going to be x equal the 8 is repeated 3 times. See, that's what I highlighted in green, the 3/8. Then I'm going to keep the cubic root symbol. And then I have the 2 that is not repeated 3 times. So I'm going to multiply them. 2 times 2, that will give me 4. And this is the answer of, this is how you do question number 1. See, I told you, it's going to involve a little bit more thinking. And the same thing is going to happen in problem number 2. Let's go to that one. All right, here's question number 2, the last one of this assignment. Remember, I started backwards. Well, I started number 3. I did 3, 4, 5, and then I did 1 and 2. Okay. And here we go. They gave you another equation of the form x to the third power equal q. And what we want to do is we want to find out who's x, what number you raise to the third power that will give you this big number here, 3087. You can see it's a little bit different than the original problem. Okay, and imagine every time you have these equations with the third power, the x to the third power, imagine a cube where the inside of the cube is 3087. Now, one of the things I suggest, you try to find this number in the table, the green column, and you're going to see that this number is not here. Okay, when it's not here, you're going to have to use the calculator. Every time you have a cube that you know the inside, you want to find the edges where the x's is, okay, that I highlighted in green. What you're going to do is you're going to do the cubic root of that number. And look what happened when you do the cubic root. Okay, let me type it in. So cubic of 3087. You can see I got a long decimal. It means this number is not perfect cube. That's why you didn't see it in the table. It's not perfect. So what we're gonna do? We're gonna do the tree. Okay, that's what we're gonna do. Now I'm gonna show you how I do it with the calculator. Now, this number is not even, so the next number I'm going to try. So in other words, when I say even, it cannot be divided by 2. Watch it. I'm going to try to divide it by 2. See, I got a decimal. So no decimal, okay? The next number I'm going to try after 2 is 3. And look, it worked. So I'm going to put 3 and 1,269, okay? I already know 3 is prime. Now I'm going to do the tree again of this number. So I'm going to try 3 again. I'm going to click the blue button. And my last answer was 1,269. Click on the A and S key. That means the previous answer. See? And divide by 3 again. Okay. And you can see, oops, hold on a second. I think I did a little mistake. Oh yeah, I did this. I put 3,087. Let me see. Yep, that's what I did wrong. I put here. Look at this second line. I put 3,807 when it was 3,000. My bad. I apologize for the mistake. 3,087. See, there you go. Okay, so I divided by 3. I got now let me fix my tree here. Okay, so I'm going to erase this number and I'm going to be putting 1,029. Again, I just did a mistake writing the number 10,029. And then when I do the tree, I get 3. See, because I divided by 3 again, and then 343. I know 3 is prime. And look, this number here, 343, if you look at the table in green, you're going to find it. Look, here's 343. And basically, that means that 343 is a perfect cube. And we are in row 7, see? So imagine that instead of doing a tree with 2 branches, I'm doing a tree with 3 branches. And in each branch, I have a 7 because 7 times 7 times 7 gives me 343. Now I'm ready to do this because cubic root, this symbol, cubic root, means you're looking for a number repeated 3 times, and those are the 7s. Okay? So I'm going to have x equal, the 7 is repeated 3 times. Then I'm going to put back the symbol of cubic root. And what number is not repeated 3 times? These 2 3s. And you have to multiply. So 3 times 3 will be 9. And there is how you do this question.